This is lesson 1.1, Introduction to Rational Numbers. A rational number is a number that can be written as a fraction. This includes all integers, whole numbers, natural numbers, and decimals, both terminating and repeating. Most of the numbers that we deal with in Math 9 and through most of high school math are rational numbers. The opposite of a rational number is an irrational number, and an example would be pi, or 3.14159, continues forever in no common pattern. This graphic here kind of shows the difference between the different types of numbers that we know. So we have natural numbers in here. Those would be all integers that are positive. So 1, 2, 3, 4, continuing in that pattern. Of all these options, the fewest are natural numbers. Whole numbers include all natural numbers, but it also includes 0. Integers include all whole and natural numbers, but it also includes the negative versions of those numbers. So we've got +1 and -1, +2 and -2, etc. Rational numbers now include all of those three that we just talked about. So we can have fractions, both negative and positive, decimals, both negative and positive. You can have decimals that terminate. So this one, like 11.23, that terminates. Or you could have one that repeats, like 7.12 with the line over top. That means it's actually 7.12121212, repeating forever. The reason, again, that pi is considered an irrational number is because this pattern, yes, this goes on forever, but it's not a pattern. They're basically just random numbers that have no pattern of repeating. So that's why it's considered irrational. To compare and order rational numbers, we first convert them so that they're all in the same form, so whether they're all fractions or all decimals, and we use a number line to help order them from smallest to largest, or vice versa. So this example, we're given a bunch of rational numbers and we want to order them from the smallest to the largest. These are in different forms, so let's all convert them to the same form so that it's easy to compare, like comparing apples to apples and oranges to oranges. It doesn't really matter which direction you convert them to. I think it's easy to convert them to decimals, so why don't we try that? So if we rewrite these numbers, 1/4 is 0.25. We've already got this one as a decimal. 2/5, you can either do that into your calculator. It's going to be 0.4. The reason I know that quickly is because if you divide 100 by 5, you get 20. And then there's 2 of them. So you've got 40, and that gives us 0.4. 1.5 is already a decimal, and 1/3, you could again put this on your calculator, or you might know that it's 0.33 repeating. The 3's go on forever. Now we want to order them from smallest to largest. So let's see, the smallest one is going to be 0.25, because 25 is the lowest of those decimals. But then the next one's kind of tricky. Which one would be smaller, 0.33 or 0.333333 going on forever? Well, actually, the first option is going to be smaller because the third decimal spot here, in this case, it's going to be 0. In this case, it's going to be 3. 0 is less than 3, so therefore this number is slightly smaller. So then the repeating one is next. Then we've got 0.4, then we've got 1.5. So then just for our final answer, these 3 dots mean therefore, we can convert them back to their original form so we know exactly which ones are smaller than the other ones. So our 0.25 was 1/4. Our 0.33 was already written as 0.33. The repeating one had been written as this. 0.4 had been written as this. And then we've got our 1.5 at the end. So that is our final answer, rearranged from smallest to largest. Okay, next question. We want to identify a fraction between 0.45 and 0.66. Obviously, these are given in decimals, but we want to get a fraction between these two. So the first step would be to convert the numbers into fractions by placing this part of the decimal over 100. So step 1 here, our numbers are going to become 45/100 and 66/100. You can check this on your calculator as well if you forget, but you just place the decimals, anything to the right of the decimal goes over 100. The second step is you're going to choose any numerator in between these two. Now it's easy to compare because they're both over 100. So what would be a number between 45 and 66? Well, why don't we just pick 50? So 50 is between those two, and then this is going to be over at 100 as well. So 50 over 100 is between these two fractions. And the third step, we want to reduce it. So 50 over 100 is nice and easy. This is just 1/2. So the final question was saying identify a fraction between these, so it's 1/2. If it said identify a decimal, you also could have said 0.5 and then converted that to a fraction. Next question, which of these fractions is greater? So I have two methods here that you can use. The first method would be to manipulate the fractions so that they have a common denominator, and then you just look at the two fractions, whichever numerator is bigger is the larger number. So let's try that one first and see what we get. These currently do not have a common denominator, but if we multiply this second fraction by 20, then we would have a common denominator of 100. So we convert them. So we've got 52 over 100 and 40 over 100. Okay, and now it's really easy to figure out which one's bigger than the other because you just look at the numerator to figure out which one's bigger. So 52 over 100 is larger than 40 over 100. Method 2, another way you can do this is to convert the fractions right into decimals and then just compare them on a number line, whether you draw that number line out or just think about it in your head. So if we're converting these decimals, anything over 100 is really easy to convert to a decimal because it's just 0 point whatever the numerator is. And then 2 over 5, converting this to a decimal, we already went over this today. You can either put it on your calculator to get 0.4, or you can convert it to a fraction like this, 40 over 100, and then know that that's going to give you a decimal of 0.4. Now that they're both in decimals, you just ask yourself which one's greater. Well, we already know 0.52 is bigger, but now that they're both in decimal form, it's a lot easier to tell which one is bigger than the other. And our last question, again, two fractions, same idea, which one of these is bigger? And we can use either of our two methods. So I'm going to use method 2 in this case because 8 and 3, they don't have a super easy common denominator to find. So instead of doing all that math, I'm just going to right away convert them to a decimal and then see which one is bigger. So 7 over 8, you might not know that off the top of your head, but if you do that in your calculator, you're going to get negative 7 over 8 equals negative 0.875. Don't forget the negative. And then we've got negative 2 over 3. You may know that this is negative 0.66 repeating. And again, if you didn't know, put that in your calculator. And now we just compare which number is bigger than the other. Now it's a little funny when we have negatives because you might look at this and say, well, 0.875, 875 is bigger than 66, so this number must be larger. But because we're dealing with negatives, if we looked at the number line, this is 0. Well, this is going to be negative 0.875, and somewhere around here will be negative 0.66 repeating. So actually, the 0.66 is bigger because as you go this direction on the number line, the numbers get larger. When you go this direction, they get smaller. So when you're dealing with negatives, you have to remember that it's not just the face value of the numbers that are bigger. You have to look at how they relate to each other on the number line. So therefore, negative 0.66 repeating or negative 2 over 3 is greater.